Okay. So, use stock type is the variable that turns on and off the limits. So when you read limits must be enabled, see use stock type, that's what they're talking about. This has to be on. Now, there's two ways to use it. We can use the limits as defined here. So we can actually put in, the upper and lower boundaries of where we want this box to be. Now, unfortunately, this box is basically relative to wherever your 0 point is. And your 0 point in Mastercam is typically going to be the center of rotation for a trunnion. For a Gantry style machine, it's going to be basically wherever you set it on the table. So not only do you have to know where your work offset is on the table, you have to know how much travel you have in each direction relative to that work offset. So it gets a little interesting. Especially if the Z value that you're outputting is the pivot point of the gantry. Because this might be something like, in inches, maybe the lowest this can go is like, 31.254 for the lower limit. That's low. And then upper might be, something like that. So you have to measure all those numbers and put them in. I like doing this. We zero out the limit values. And we set the size of our box equal to our stock definition. And you say to me, well, that's great, but if I'm only retracting to the edges of my rectangular stock, when I go to rotate, I'm going to gouge. And yes, I agree with you. But we have this bad boy, clear stock. And this is an incremental offset to the stock definition for the transition boundary. So if we go and say, I want to clear my stock all the way around by 6 inches, that's what this will do for you. And it depends on the shape of your stock, because the only thing we get to define is a box. We can't define a cylinder or a sphere. Those options exist in the 5-axis toolpaths. So if you want to use that safety zone and you want to do a 3-axis style toolpath, you should check out the triangle mesh toolpaths, because you can do a 3-axis style path. You can get all of the retract motion you want, and you only have to worry about the null tool change, retract, and approach. And null tool change, retract, and approach is different than a reposition in the middle of the path. There's an option in here. This control allows retract on rapids too. So in other words, if we're getting rapid motion, do we want to allow this retract behavior? Yes or no? Typically, we do leave it set to 1. You just want to check the output. Okay, so we enable limits, set it to 1 so it reads it from the stock definition, and then 0 the limits in the post. We need to do this. This is important if we're going to use stock definition. And actually, I think these have to be zeroed if we're using the MR6 safe Z retract. I think that's a requirement there. And we can decide, you know, how much clearance, how much safe clearance we want on the stock definition. So stock or clear stock, I'm going to set it to 3. So that's turning on the stock stuff. Now, MI8 controls that safe retract and approach behavior. So let's say that we're working on, oh, this is 2018. Let's go back here to the test file that we had. This is the one. There we go. Okay. Okay, so we've got some operations set their retract to 2 inches incremental for each operation. If we go and we look at the miscellaneous values, the post itself has a set of default values, default integers and default real numbers. So if I turn on automatically set to post values when posting, it will actually grab all the values from my post, load them in here, and when I post it out, it's going to use whatever the default values are in the post. You can use just the set to post values button if you want to grab those. You can also use set to operation defaults. In this case, the op defaults are mostly 0 for this type of, you know, multi-axis curve. It's only got 2 for misc integer 1, which isn't even used. So if I set to post values, here's all of the default values that exist in your post. Where do these defaults exist? If we pull up the post processor and we scroll all the way down to the bottom, near the very bottom is a section called post text. Now, this is the X style. So from Mastercam X all the way to 2017, the formatting of this was kind of just text-based, and it was just output in the order that it was output in. Whatever the, you know, formatted order internally inside all of the DLLs that build this together, it would just output it in a certain order. Now there's a structure to the post text. So starting with 2018, I can do this. Just want to show you what the post text looks like in 2018. just pull up null default. I don't want to go through with the upgrade at the moment and have to show, you know, it's not really that necessary at the moment. So 2018 mil posts MP fan. And down at the bottom is the post text section. And what you can see is that we are now formatted in XML. And XML is a markup language that uses tags to control the formatting and the ordering of data. So here you can see that this is the control mill default. This is equal to control mill default post text settings. So defaults are just that. These are the default values that get used when we don't have a specific post in a specific location linked. So one of the issues we have, when you open up a post and you save it off with a new name, and then you go through the process of setting up the machine definition and the control definition. When you use the control definition, oh, look at that, this hasn't happened yet. So let's do this. Let's go into 2017 because I need to add those default values. I'm going to save this. We're going to go machine type design, file new. And I'm going to open up the control definition for the OKK. And right now you can see that in this OKK we're set to the default settings for the control type. Default settings for control type live inside the mcam control file. You can set default miscellaneous integer and real numbers in the default settings for the control type. But unfortunately, in the default settings, you can't really save these strings into the default. You'll notice it says system text. The text is not editable. And it's because we've opened it up and it's got these defaults in there. You can get fooled into thinking that they're there when they might not be. If we select the actual post in the drop-down list, and we go look at these text settings, we can go and we can change what we want these to be. So for example, maybe we want to set up our posts to have this be high speed. I'll call it HSM mode. And maybe we'll set up MR3 to be corner rounding value. So we're going to enter the actual corner value in MR3, miscellaneous real 3, but it's got to be basically, we're giving a note here. It says MI1 must be on. Okay, so in order for this corner rounding value to output, we also have to have misc integer number 1 turned on. I can save these into this post processor by making the edits here. I have to make sure that the post is closed, that I don't have it open in a text editor. When I make these changes and I hit save, I've just written these values into the bottom of the post. So if I go back and I open up that post, and we scroll down to the very bottom, we've just added or written a new control mill section that has text strings that are specific to that post. Actually, specific right now, tied into a control definition, a mill control definition with this exact name. So when I load my machine, it loads the control. The control goes and opens up the post and makes sure that it has a section that has the exact same name as this, and it loads these settings. But there's this situation that happens. The control definition points to a static file path. In other words, this post located in this specific folder gets these settings. If I upgrade my post, my machine, and all that from 2017 to 2018, what ends up happening is in my 2018 version, we will have gone and grabbed default settings for control type. The problem is my default settings in the text section don't match my text settings in the post that I just edited. You guys see that? This is the one kind of flaw and limitation with this control file, and I don't know if they fixed it in 2018. I've dealt with it for so long that I'm not even going to bother asking or caring. What I do is I make my edits to my post here, and I go into the post processor, and I'm going to copy everything. Oop. So I'm going to put my cursor there, just underneath, or just at the start of the misc integers. Scroll all the way down, hold down Shift, and click just after the last number string here, just before control text end. And I'm going to copy those values. Then I'm going to scroll back up to the defaults, because you'll notice we actually have a third set of settings in here. We have a set of settings that is tied into the Generic Fanuc 5x mil control definition. We can have a whole bunch, and sometimes you will see a whole bunch of different text sections in there. But this is the important one, which is the control mill default values. You must edit the default strings manually. The nice thing is that if you do edit these default strings, guess what these are? These are now the defaults. So the default values that will be used no matter what control definition is currently accessing the post. If the control definition doesn't have the exact file path in it, if it has, say, a slightly different file path, like you've upgraded from 2017 to 2018, so the file path doesn't match, it will now pull in these values. So I'm going to load these for the defaults. and then we'll save it. And I'll close the post. We'll go back to the control definition manager. And inside the control definition, we'll select that particular post. And we'll go to the miscellaneous integers and real values. Now, what this should do for us, we should be able to set default values here and have them save it into the post processor. So for example, if I set HSM mode to 1 to be on, absolute ink, we're going to leave absolute. Let's say reference return, we're going to make the default for that 2, and I'll show you why in just a little bit here. Now we've got some options. These last 5 miscellaneous integers going down all have a different important function. Add work shift. 0 is origin, 1 is WCS origin. Miscellaneous integer number 6 is a fairly important miscellaneous integer. It determines whether or not the origin of our operation comes from the WCS origin or it comes from the tool plane origin. The reason that that's important is if you especially on a 5-axis machine, if you want to go and set a work offset to say the center of a bore on a particular face, a lot of times you actually want to move the origin of where your work offset is going to be relative to your original WCS origin. By default, this post does not let you do that. By default, we only output all coordinates relative to the WCS origin. For MI6, add work shift is automatically disabled for all 5-axis toolpaths. Very important to note. Okay, if you've got a 5-axis toolpath, if mil5, which is an internal post variable, is equal to 1, then it will always come from the WCS origin. Setting this to 0 tells it for tool plane based toolpaths to calculate the origin relative to the tool plane origin, not the WCS origin. But we'll leave the default 1 for now. MI7 allows you to turn on and off the retract to and from the limit behavior. So MI7 actually has to be 1 if you want your retract to actually take effect. So not only does this have to be greater than 0 or negative, I think the negative option still works, but this has to also be 1. A lot of the times we would actually disable this retract to and from the limit if we're working on an internal cavity, especially on like a Trunnion table. So if you're working on an inside angled pocket or something and you're doing multiple cuts, we would want to actually disable that retract behavior. Okay, but we're going to leave the default set to 1. Retract at the tool change. Off, null, actual tool change, both, negative, blah, blah, blah. So we'll do -3, which is essentially everything. Do it at both tool changes and on the chains. Nutating bias. Basically, miscellaneous integer 9 and 10 serve the same function. Jeremy says he kind of handles that with forced tool change in the toolpath. That's certainly an option. That does change the NCI G code from 1000 to 1002 to make it go through the actual tool change. And that way everything is, every option, every path starts and ends with an actual tool change. And that's certainly a valid way to do it. That's not, I mean, there are certainly, process reasons why you would want to do that. It makes restarting much easier, obviously. Maybe you've got a huge, long finishing program, though, where you're going to finish in 10 different areas. It takes you 10 different tool paths. It's all the same tool. And really, you just want to be able to start at the beginning, but you want to be able to control the retract behavior as it moves between these different little sections without having to break it all up. So I agree. I mean, there are always going to be different ways that you want to run your code in your machine, and that's perfectly valid. I'm trying to show you the tools that are available to you inside the post and how they work, because we've had these options for a long time, and I think there's a lot of people that end up using these posts or posts that are built using this generic Fanuc 5X post as a template, but they they don't necessarily know all of the different options that exist and how to use it. Yeah, no, totally. But that was a good comment, though, Jeremy, for sure. So MI10 is an important switch for us. It's not going to be as important for this OKK machine. And the reason is that we've got a limited positive travel range anyway. So the machine limits should actually help tell the post to always stay in the negative range. But what MI10 does is it temporarily restricts the travel range of the secondary axis. So if you do happen to have a machine like a Gantry that might have plus or minus 90 or in this example 135 available on the secondary, choosing an option will let you either always stay positive or always stay negative within that toolpath. In other words, it temporarily restricts the travel range. We use this a lot with the Haas VFTR 5-axis post, which would be this bad boy right here. Because the secondary basically has, plus or minus 200 degrees or something like that, plus or minus, it's more than 90. It's like 120. Yeah. But basically, by default, I think positive is facing away from the operator. So a lot of the times when you're programming, maybe your plane is flipped around, or the post, the last position is closer to the negative side, so your last toolpath went in the correct direction, but now your third toolpath or whatever forces the table to go to the opposite side. And in those cases, this switch is useful for limiting or eliminating that behavior. So MI10. The operators get mad. Yes, they do, and rightly so. It's a pain in the butt to be responsible for a part that you can't see. Especially when you're running through it the first time. So always stay positive, always stay negative. We have that choice. Now you'll notice it says this is for non-nutating. MI9 is the exact same option. It is, here they're saying it's a bias calculation, but it's the same thing. Either go positive or go negative relative to the secondary axis. But nutating, anytime you see the word nutating, we use the nutating stuff inside the post. Let me open it up. And we use it for top map. Now, top map is something that we'll be getting into. I don't think it'll be this Thursday, but it'll probably be next Tuesday. So one of the functions that we have available inside this post, and of course I say, yeah, we'll get into it next Tuesday, and then I start explaining it, right? But I just want to talk a little bit about it without going into detail. P Mutate Restore is the name of this post block here. And it is used to reset rotary axis 1, rot-dir 1, rot axis 2, and rot-dir 2. It resets the 0 and the direction for those variables. So initially, when we first set these up, we want to make these settings here match down here if we're going to use top map. Now, top map is really the architecture that exists inside the post to support tilted work planes. Tilted work planes is G68. Well, I guess with a single axis of rotation, it's G68 or G68.1. And with two axes of rotation, it's G68.2. And this has quite a bit of advantages, especially on a machine like a Gantry. So normally on a Gantry style machine, we can only use canned cycles if they are aligned to a plane. So if they're aligned to the top plane, which would be G17, then we can do all our normal drill cycles. If they're aligned to one of the other planes, we're either going to be in G18 or G19, and we can still do all of those drill cycles. We can also use cutter comp. With G68.2, it gives you the ability to program as if whatever angle of rotation your head was rotated at, that the coordinate system is aligned so that the z-axis of your coordinate system is aligned to the spindle axis of your tool. And therefore it allows you to do things like use canned cycles and drilling and use cutter compensation to size your parts on a Gantry style machine, you know, cutting, you know, a plane that's not normal to anything. So internally, rather than writing a whole different section of variables to support top map, one of those brilliant post writer guys got the idea that, hey, well, we've already got this other set of variables we created for nutating machines. Why don't we just reuse those so that we don't have to write a bunch of other crap? And we'll just put in some tricky little post logic to make top map work with the nutating stuff. And then they neglected to kind of tell a lot of people how it works, which is what I'm trying to do. So P Mutate Restore, we make sure those settings match. So this would actually be minus vec y. We don't worry about the nutating primary angle because it's not really a nutating machine. And these shift variables here typically only apply with a table. You can use them with the tilt head table and the head, although it's not as common. Because really here we're talking about offsetting based on the primary rotation center to the secondary rotation center. But this is for basically 3-axis operations. It says here, nutating axis shift, used when calculations are based on M-type 3 or greater, and it should say this. Or I was going to do like a down arrow. Or if we are in top map. So top map and tool plane toolpaths use axis shift above. 5-axis use these. So top map and tool plane use this. 5-axis toolpaths use this to shift around. And part of the reason that they do that is because these values, the N underscore shift axis X, Y, and Z, have the option to get overwritten. And they get overwritten. Let me do this. -3, no bias on the nutating, and secondary. We'll just leave it off for now too, because the post should take care of that. So I'm going to save these default values, and then we'll say OK. And let's get our sample file here. OK. For 5-axis toolpaths, we have the option to enter an X, Y, and Z shift value for each different toolpath. So this allows us on a toolpath by toolpath basis to be able to tweak and blend one cut in with the next. And the way that it does that, if you want that functionality, you have to enable it. So to enable it, it is Shift MISC R. Read the axis shifts from the MISC reels. Do you want to do that or not? Now, if you don't ever intend to need, yes, this is for 5-axis only. So what we're doing is on the 5-axis toolpaths, we are overwriting the nutating axis shift values. 5-axis use these. Top map and tool plane use axis shift above. So top map and tool plane toolpaths use those. Yeah, but again, in order for us to be able to shift these around on an individual toolpath basis, we also have to turn this on. So it either has to be 0 or 1, or yes, which is the same thing. Well, internally, it uses N underscore S axis X, N underscore S axis Y. And I don't believe it adds them. I believe it overwrites them. I mean, we can check. And I'll give you a definitive answer here. So N underscore S axis X if cut type and top map and previous M type is greater than 2, so that's nutating, else S axis X equals MR7. Okay, so it will overwrite. So it will actually use both. If Shift MISC R is turned on, the nutating values for 5-axis toolpaths, I guess that's with and top map, so top map has to be turned on. Let me check and make sure, see if there's another part of this too. Hold on. Yeah, because this is the only place where it's red. Basically, if there's any shift values at all, because this gets the vector length of this vector, it sets do shift to 2. Do shift equals 2. Yeah, so I guess that's not really correct. It says 5-axis use these, but previous M type greater than 2. It's just testing to make sure it's not 0. So that would be 5-axis, but we also have to have so here's the part that's a little weird. Top map has to be enabled for this code to execute at all. So we have to, but it also says and cut type. So if cut type, which means cut type is not 0, so it's not a tool plane based tool path. I'm just wondering if this should be like an OR. And previous M type is greater than 2, which would definitely be a nutating machine. So it's basically like if it's a 5-axis toolpath and you're using top map and you're using a nutating. So since it has to be a nutating machine no matter what, I don't know. I think that's kind of a lie. I think where it says 5-axis use these, I don't think that's true. I think we have to have nutating machine turned on. So what I see in here is that, and by the way, P shift misc R is in your regular post. So this is already in the PST section. And you can see right here, if shift misc R, if cut type, which says we're in 5-axis mode because we're not doing cut type 0, and top map, which means we've got the top map switch turned on, and previous M type is greater than 2, which has to be a nutating type machine. Unless for some reason the post manipulates this in 5-axis mode, it just says, oh yeah, previous M type is 3 or something like that. Then I guess this could be used for 5-axis, but this right here tells me that's not exactly true. Now, there's nothing that says we can't do this. We can force it to use, you know, for 5-axis toolpaths, we can force it to use the nutating shift values if we want. By default, it really S-axis X is going to get red if shift misc R is turned on. So the question is, does it add them to the S-axis? The answer is it actually overwrites them if shift misc R is turned on, and since we're not doing nutating, it's always going to hit this else. Because remember, we've got so basically this says, hey, we have to be in 5-axis, we have to be in top map, and we have to be a nutating machine, and then we're going to use the nutating S-axis vector. Otherwise, we're just going to use the S-axis vector, S-axis X, Y, and Z. And in that case, it just overwrites whatever the current settings are. And then it updates them. And the updates right here save the newly set values into the previous values. And that's why you see this line of updates right here as well. First we set them, and then we save them into the previous variable slots. Okay. So again, if we enable this, then we have to use it. If we say shift misc R, then we enter every axis shift into MR7, 8, and 9. Yeah, then it tests to see what values it has in the PSB for further calculations. Yes, I mean, it does the shift work in the PSB. Yeah, so in the PSM, if we look at axis X, basically it says, hey, if there's any shift values at all, do shift equals 1, else do shift equals 0. So if there is no length to the S-axis either in the post here or having been set by the misc R values, do shift gets set to 1. Then we update do shift. Then if we have nutating shift values, we actually set do shift equal to 2. And do shift, if we search for that, so if do shift, and so here is really calculate the positions for the secondary basic to the part 0. Here's where we start doing the actual calculations to rotate stuff around. So if do shift, and if do shift equals 1, then we check our intersect. So if our intersect is 1, we set this vector by taking this guy and we rotate it around the y-axis. And if our intersect is not turned on, then we just rotate it positive. So instead of negative S vec rotate, we do rotate point. And rotate point uses a helper variable. So the rotate point function, well documented, so it's all in the documentation. You can read about rotate point. Rotates a 3D vector x by angle A. So you can see that in the little description there, they've got return equals rotate p a comma x. Returns the rotated vector. Requires helper variables to set rotation axis and pivot point. And basically we have to set point fix x, y, and z prior to calling the rotate p function. So that's done somewhere else in here. But this is the logic that does that shift. Yeah, I mean, this just gets chock full of stuff in here. All right. Let's go to this here. Okay. So when we look at the miscellaneous values, We're just about done, so we've talked about a lot of these misc values to kind of introduce them. Starting next class on Thursday, we're going to go through and we're going to show some practical examples. So, write some toolpaths, post them out with these values, and then change the values and watch the code change and see what happens. Before we do that real quick, when we went into the control definition and we set those default values, it looks like it didn't change them. So that's one of those annoying things, is that you can go into, yeah, look at that, it didn't change them. So you can go into and you can change all those default value settings, but they don't actually change the defaults in your post, which I find aggravating. One of the things we can see here, just by looking at the text format, in order to set a default value for a miscellaneous integer, we follow the text string with 2 forward slashes and the default number. So if I want to make that default to 0, and I want to make 10 default to 0, I can do that. If I want to make this default to -3, we can do that. Enable retract is on. Add work shift is set to WCS. We know we want the default to be 0 for initial primary and secondary bias. I mean, default, or 0 is really the default anyway, but it doesn't hurt to set it. We set the default here to 2, the default there to 0. We'll set our default mode for HSM to 1. Now for the miscellaneous reals, we have 2 default values. We have an inch value and a metric value, and you must supply both. So for the right angle head activate, we could just leave there, being no default, which would be fine, but there's nothing wrong with setting them either. And we'll say that default corner rounding value is 2 thou for inch. And we'll say it's 0.05 for metric. We'll make the default for the safe Z retract. We'll make those 0s. And same for 10 there. Now by setting the default numbers here in the defaults, that's what's going to come up, but we should also copy, let me get all the way there. We should also copy the misc integers and reals, go down to our OKK, and I'll paste those in so they all have their defaults as well. Now in this case, with this particular control definition, we don't really ever plan on linking the generic Fanuc 5x milpost to this OKK, VCX 5x post processor. Now the reason is that we're taking this template file and customizing it. So there's nothing wrong with deleting unused control definition text. Just make sure you don't erase the actual name of the control definitions that you want to save, and all of those sections. If you erase a section by accident, it's not going to kill anything. But then, if I were to do this and save it, those miscellaneous integers there just would get the default text string. It would just say, misc integer 4, misc integer 5, misc integer 6, instead of having the actual, function that we want them to perform. This is Control Z, there we go. So here, I've got my saved OKK values, and this is fine, right? Because I can put these misc integers in, I can change their values or whatever. But there's one more trick I want to show you guys. As long as you have control definition defaults inside the post, these can be used to override everything. So I can take my control mill for the OKK. I have to leave this control text end, but I can just delete that. So that leaves me with just my control mill default settings. And there's nothing wrong with doing that. If I go back in here and I reload the machine definition, basically it just grabbed my default values from the post for those text strings. So if I go into my misc values, it grabbed my defaults. If I say set to post values, these are my default values, and it just grabs them. I like doing it that way. I think it's a smarter option to be able to have one set of values and know what they are, as opposed to wondering, where do my post values come from? Does my post have a control text setting for the control definition that I'm using, and is it accurate, or do I just need one set of values? I believe that I actually stole that little tip from In-House Solutions. So when I was looking, I saw that unblock it here. Yes, I want to open it. Don't ask me that. Of course I want to open it. And if we go down to the MP master, we have mill default. And you'll notice that we don't have a section that says control mill MP master. We just really don't need it, because MP master is meant to be customized. So what this gives you is, one set of integer and real number values, and you can go in here and put in your defaults as you see fit. And it's the same thing that we did here. We have one set of values. They are the mill defaults, and we set whatever we want the defaults to be, and then we can pull in those values by clicking on set to post. We can tell it, just automatically use those post values whenever you post. I don't even want to mess with these. If you want, you can do that. I like having the control. So I like being able to come in here and change values and get different post output that I actually desire. Okay, but I wanted to point that out about saving the text strings. So in general, I recommend when you first set this up that you do go in, so save, machine type, design, file new, and we're going to go control definition manager. We're going to open up the OKK. Boom, boom, boom. So when you select your post in here and you add it to the control definition, and then you go in here and you make your changes, right? So I want to set this up for something, and I save it. So I make all my changes here to this linked post processor, and I save it. And when I exit, and I now go look at my post, where did we go here? Oh. Okay. So again, when I make my edits through the control definition manager, I like that because there are some text strings that it's going to be hard to guess. So here, oh, we're looking at our defaults, right? So we got to go down to the new post that's been added, and you can see here, testing, 1, 2, 3. Now, this is great for adding misc integers and reals, but I think you can see with the misc integers and the misc real numbers, there's a method to their madness. Each string is named from 1 to 10, and it's followed by the default values, and that's all great. But what about things like the drill cycles? So one of the cool things is, you know, there's a lot of options that you can customize. Mill drill cycles. So for example, maybe we've already got drill cycle 9 set up for a subroutine call or something like that. You'll notice here for the default setting for control type, I can't edit this stuff. System text is active. The text is not editable. Okay. I actually have to go and grab the actual post, go into the text section, go to my MISC, or not MISC, but go to my mill drill cycles. Let's go look here. So let's say drill cycle 10. And I want this to be probe bore 4-point. And I'm going to scooch all these down a little bit. Okay, so feed rate, we can leave feed rate. Dwell, we can leave dwell. We don't have to. We can actually disable these or change their name if we want. But then we get down to something like the first peck variable. And so instead of first peck, I'm going to call this one bore diameter. And then we're going to have safe plane. And we're going to have an entry for probe ball diameter under feed rate. I call it probe touch rate. And leave all that there. And who knows? Well, let's say that I filled those out too. But for drill cycle number 9, I also have mill custom drill parameters. So custom drill parameters for drill cycle 10. So here's custom drill cycle 10. Scoot a couple of these down. Come Okay. And maybe parameter number 10 is going to be tolerance value. Maybe this is a standoff. Maybe this is over travel. And update. And work offset update. And we've got one in there for report. Okay, 0 equals no, 1 equals yes. And so we've added these custom drill parameters. And if we go to the mill drill cycles, we've added these custom descriptions. I think we've got all these. And we'll add a custom can cycle description. So I've saved that. And we'll make sure that the post is not open. And now when I go to open the post, we should see those text strings down at the bottom. And the important part of linking it that way is so that we can find out how this is structured here. Oh, I put it in drill cycle 9 instead of drill cycle 10. Because you'll see down here, drill cycle 10 custom parameters, and I've entered the string values here. Okay, so this should actually be, I believe, drill cycle. Oh no, you know what? This is drill cycle 9, even though it's drill cycle 10 custom parameters. And I think I'll show you why. Guess we'll see it here in a second anyway. So what happens is it actually saves all that info here inside the machine toolpath copy, which is why it's important that you reload your machine definition if you want to see those changes take place. Yeah, it is drill cycle 9, so. So what we're going to do here change it like that. So I entered it in the wrong field. Okay, so last thing, do the replace. We go and do a drill toolpath. You have to give at least 1 point, and then cut parameters. So probe bore 4 point, and when I turn on apply custom drill parameters, you can see that it's actually grabbing those strings and changing the string inside the dialog box here. And what this ends up giving us is 10 extra drill parameters that we can pass with this drill cycle. So in total, we actually get 6 parameters here. We get 10 down here, so we get 16 possible values that we can pass along. And if I go back to my tool page, you notice what you see here? So I actually took the word feed rate, and because we're doing this particular probing cycle, it says probe touch. If I go back in there and I choose drill counter bore and I go back to tool, it says feed rate. But again, I can rename not only these values here, but some of the values here on this page by doing that. So I think some of the other ones I can rename is like a retract, depth, top of stock, clearance, or something like that. If I wanted to rename those, you know, probe start height instead of retract, I could do that. So we'll add that there. Oh, tool does not exist. Okay, fine. Okay, fine. There we go. Okay. So that was the last thing I wanted to point out, was changing default text strings and changing default values for both the miscellaneous integers and real numbers, and you know, some of those drill cycles as well. All right, we're going to wrap it up anyway, guys. So Mike, thank you, sir. And if there's any other final questions, I'll be happy to answer them. Otherwise, we're going to wrap up class for tonight. Yeah, absolutely, guys. I'm glad you say that. It's I always have a hard time gauging whether, you know, what, you know, the particular stuff I'm going over is useful or not. I like to think it is, because I think a lot of the stuff is you know, not well known or just barely touched on, and so being able to provide that context and that depth is something I really like. So it's good to hear that. Cool. All right, guys, I don't see anything like, hey, I need you to explain this, so we will pick it back up Thursday. So thanks, guys. Let's save this and shut down the recording. Let's get rid of all that. And cool. And I will wish you guys a great night.